Our solar system is a familiar place, a cosmic neighborhood we've explored for centuries, filled with planets, moons, and countless smaller bodies orbiting our sun. But every so often, something extraordinary happens. Visitors from distant stars pass through, carrying secrets from far beyond our solar system, hinting at the vastness and mystery of the universe. In early 2019, Hawaii's Atlas telescope, designed to scan the skies for near-Earth objects, spotted one such interstellar traveler, later named 3I Atlas. It was only the third object of its kind ever detected, making it a truly rare cosmic event. At first glance, it looked like a typical comet, a faint smudge in the night sky, gradually brightening as it drew closer to the sun's warmth. Astronomers around the globe quickly mobilized, eager to study this rare messenger from another star system, coordinating observations and sharing data in real time. Normally, comets form glowing comas and long streaming tails as they heat up, revealing their icy, dusty makeup and offering clues about their origins. Scientists expected 3I Atlas to behave the same way, hoping it would offer a rare glimpse into the chemistry of distant worlds and the building blocks of other solar systems. But this object quickly defied expectations, behaving in ways no one had predicted. Instead of following a smooth, predictable path, its brightness fluctuated wildly, puzzling astronomers and sparking intense debate. Then, as it approached the sun, it began to break apart, fragmenting in a dramatic and unexpected fashion. The breakup was spectacular, splintering into multiple pieces, each fragment dimming as it drifted away, leaving scientists with more questions than answers. While some comets do break up, the way 3I Atlas disintegrated was highly unusual, unlike anything seen before. It hinted that this was no ordinary icy body, but perhaps something far stranger, forged in the depths of another star system. Each new observation added to the mystery, challenging our assumptions about what kinds of objects roam between the stars and what secrets they might hold. Was it just a fragile comet, or could it be something more, an object unlike any we've ever seen before? The data became a tantalizing puzzle, and some began to wonder, could this be more than a natural object, perhaps even a relic from another world or civilization? The story of 3I Atlas was just beginning, promising new discoveries and deeper mysteries as astronomers raced to unlock its secrets. Science thrives on caution, but sometimes caution can blind us to the truly new. My career is about asking big questions, even those that challenge conventional wisdom. When Oumuamua, the first interstellar object, showed unexplained anomalies, I suggested it might be artificial, perhaps a light sail. That idea met resistance, but when 3I Atlas appeared and behaved strangely too, it reinforced a pattern. Should we always assume these objects are natural, or consider artificial origins as well? My role is to keep all possibilities on the table, guided by data, not comfort. As a physicist, I look beyond earthly analogies and focus on the fundamental principles at play. If an object's behavior defies cometary physics, we must explore every explanation, including the artificial. To do less is to ignore our duty as scientists. The universe doesn't owe us familiar answers. We must be ready to confront the unknown. The data on 3I Atlas revealed a truly peculiar object, one that immediately caught the attention of astronomers around the world. Its most striking feature was its early, gentle fragmentation, breaking into pieces far from the sun, at a distance where normal comets remain intact and stable for much longer. This suggested extreme fragility, unlike any natural comet we know. The pieces seemed to separate with almost no force, as if the object was held together by the weakest of bonds. Another anomaly was its lack of a strong rocket effect, which is usually seen in comets as they approach the sun. Comets usually get a push from jets of gas as they heat up, but 3I Atlas's trajectory was almost entirely governed by gravity, with almost no deviation from its expected path. It produced a coma and tail, but the outgassing was too weak to alter its path significantly, making it behave more like a passive rock than an active comet. This disconnect between appearance and dynamics is hard to explain with natural models. The object looked like a comet, but didn't act like one. The fragments drifted apart slowly, more like a structure disassembling than a rock exploding, as if something was gently pulling them away from each other. Imagine a dandelion head scattering in a breeze, gentle, not violent. The process was almost delicate, defying expectations of a dramatic breakup. The object's low density and tensile strength were far below what we expect from primordial ice and rock, hinting at a structure that was both porous and incredibly fragile. It was active, yet barely responded to its own activity. The usual feedback between outgassing and motion was almost absent. These paradoxes challenge our understanding of what interstellar objects can be, forcing scientists to rethink established theories and models. Was it a new kind of natural object, or something engineered? The possibility of an artificial origin, though speculative, could not be dismissed outright. The evidence pointed to something extraordinary, something that didn't fit neatly into any known category. 3I Atlas was a riddle, not just a messenger, an enigma that continues to puzzle and inspire those who study the mysteries of the cosmos. When faced with anomalies, we must build hypotheses that fit the facts. The artificial origin hypothesis offers a coherent explanation for 3I Atlas's strange features. Imagine a thin, lightweight membrane, a light sail, designed to be pushed by starlight. Such a structure would be fragile, breaking apart gently under solar heat, just as we observed. The coma could result from sublimating surface material, not deep jets of gas. This would explain the weak rocket effect and gentle fragmentation. Natural explanations require inventing new, improbable types of objects. But light sails are a known concept in physics and engineering. Even we are developing them. Sometimes, the simplest explanation is the most powerful. Science demands we follow the evidence, wherever it leads. Light sails are not science fiction. They're a real technology, using starlight to propel thin, reflective membranes across space. An advanced civilization might use them for interstellar travel. If 3I Atlas were a light sail, its wide, thin structure would explain its fragility and unusual brightness fluctuations. As it tumbled, sunlight would reflect unpredictably, causing rapid changes in brightness. Approaching the sun, thermal stress could tear it apart gently, creating lightweight fragments in a visible coma. The weak rocket effect fits little masses shed, so little thrust is produced. Is it more likely that nature makes paper-thin, fragile comets, or that we've glimpsed alien technology? The artificial hypothesis is both plausible and parsimonious. It doesn't require inventing new natural phenomena, just accepting we may not be alone. Sometimes the extraordinary is simply the logical next step. Most astronomers remain skeptical of an artificial origin for 3I Atlas. Science defaults to natural explanations, exhausting them before considering the extraordinary. Critics note that 3I Atlas developed a coma and tail, classic comet behavior. They suggest it was a fragile, fluffy aggregate from another star system, not a light sail. The weak rocket effect could be due to dust-dominated outgassing. Statistically, we've seen 3 interstellar objects, Oumuamua, Borisov, and 3I Atlas. Borisov behaved like a normal comet, so why would only some be artificial? Skeptics argue anomalies are just natural diversity, not evidence of technology. Extraordinary claims require extraordinary evidence, and so far we have only circumstantial clues. Until we find a smoking gun, the debate continues. Despite skepticism, more scientists are calling for open-minded investigation. Science should test all plausible ideas, not just the comfortable ones. The pattern of anomalies, from Oumuamua to 3I Atlas, demands we question our assumptions. If nature can mimic engineered light sails, the universe is more creative than we thought. Or perhaps, some objects are truly artificial. SETI has focused on radio signals, but advanced civilizations might send probes instead. The Galileo project, which I helped found, searches for physical artifacts of extraterrestrial origin. Objects like 3I Atlas are prime candidates for this expanded search. Intellectual humility is key. We've only just begun to explore the universe. When something doesn't fit, we should embrace the mystery, not dismiss it. The search for cosmic company is just beginning. The ongoing debate over 3I Atlas highlights a significant gap in our current capabilities. We simply need better, more comprehensive data to draw meaningful conclusions. To move beyond endless speculation and uncertainty, we must become active hunters of knowledge, not just passive observers waiting for answers to come to us. The upcoming Vera C. Rubin Observatory will soon scan the sky with unprecedented sensitivity, allowing us to find more interstellar objects than ever before, and providing crucial early warning of their approach. With advance notice, we could launch ambitious missions to intercept these mysterious visitors, capturing high-resolution images and collecting direct measurements that could reveal their true nature. Projects like the Lyra mission are already being designed specifically for this purpose, aiming to reach and study interstellar objects up close. Meanwhile, the Galileo project is building a global network of telescopes to continuously monitor the sky for interstellar objects and unexplained phenomena, pushing the boundaries of what we can detect. By gathering our own high-quality data, we can react quickly to new discoveries and, for the first time, truly distinguish between natural and artificial origins of these objects. We won't rely on chance or luck. We'll actively search for answers, determined to uncover the secrets of our universe. The truth is out there, waiting for us to find it, hidden among the stars and waiting to be revealed by those who seek it. Only systematic, open-minded science, driven by curiosity and collaboration, will ultimately settle the debate and bring us closer to understanding. The next discovery could change everything we know about our place in the cosmos. We must be ready to embrace it. The question of Three-Eye Atlas's origin is more than academic. It's about whether we are alone. The answer will reshape our understanding of our place in the universe. Finding evidence of extraterrestrial technology would be the most important discovery in human history. It would unite humanity, inspire new science, and open boundless opportunities. Even if all interstellar objects turn out to be natural, the search itself will push our knowledge and technology forward. The journey is as valuable as the destination. We must not shy away from the possibility that these objects are messages from another civilization. The universe is vast. It's unlikely we are its only technological creation. Three-Eye Atlas is a cosmic wake-up call, reminding us to stay curious and humble. Our future may depend on how we answer this call.